In this unit, we sort of wrap up a lot of the topics that we covered by looking at operations. So with operations, we assume we have a cloud infrastructure and we have to maintain that cloud infrastructure in a secure way. So we're going to talk about security operations in the cloud or in virtual environments. So as far as being in the cloud and using the cloud, or even having our own virtual infrastructure within our own data centers, we have to make sure that we design an effective data center for that type of infrastructure. And we're concerned about this in both realms because in our own data center, we want to make sure that we have an effectively designed data center that's going to support the virtualization that we're doing. And also, if we're using a cloud service provider, we want to ensure that they're following industry best practices. Obviously, the big three providers, we can all assume probably follow industry best practices. In fact, Google makes videos where they show you how they adopt a lot of these best practices. And there are many smaller cloud providers that we also might want to look at, that we want to ensure that they also are providing these services using accepted standards and things like that. So we're going to talk about data center design and sort of how we design data centers for the highest level of availability and reliability and so forth. And one of the first things we have to think about as far as data centers go is the multi-tenancy nature of these data centers for cloud service providers. They might be divided into smaller isolated networks if they're a co-location or colo data centers, which is a common model for outsourcing the data center, where we rent space in other data centers that are managed by companies that know how to run data centers for the most part. Although I've worked with a recent local provider that claimed they knew how to run a data center and didn't know how to keep the air conditioners running. Good grief. But multi-tenancy is is one of the concerns, but also something that we designed for. We've talked about this cloud management plane. So the management plane is basically how we manage the infrastructure that's in the cloud. So there are certainly some operational concerns with that as well. We have to make sure that we design for that. Virtualization technology, we want to make sure we understand that technology. If we're designing our own cloud data center, we want to know what type of virtualization technology we're utilizing and make sure that we design our data centers around that technology or with that in mind. And also with cloud providers, we also want to make sure we understand what type of virtualization technology they're utilizing, to whatever extent it affects the performance of our infrastructure. And by the way, when we talk about logical design, a lot of times we're talking about, there's the physical design, which is the physicality of that data center, the actual equipment that's there. And the logical design is sort of, what we see virtually with that data center. So some of the things we might do if we're designing a data center: separation of duties for data center staff, so that only the correct staff can access the data center in a way that's needed to do their job. Design for monitoring of network traffic, automation and the use of APIs for deployment. So when we deploy, for example, virtual machines, we use automation to do that. We have standard templates and standard methods for deploying them. We talked about that, I think, earlier in this course. Excuse me. Make sure that these design decisions are enforced and monitored. Use of software-defined networking tools in logical in the logical data center. So even though we might have all this physical equipment, we talked about software-defined networking earlier, and that's one of the tools that we have for designing our logical data centers. So some design levels: you have computer nodes, management plane, storage nodes, control plane, and network. So, and I talked about this earlier in the course. I showed you that diagram where you saw the physical and the management plane, and then inside that we had the virtualization plane, and then you had the networking and the storage and platforms. And that's the basic structure of our cloud-based data centers, or our cloud-based infrastructure. So, again, it's important to keep that in mind when we're designing our data centers and designing our infrastructure in the cloud. And don't forget about your service models. So we talked about the 3 service models many times in this course: the infrastructure, platform, and software as a service. Obviously, if in infrastructure as a service, you have the most visibility to your data center in the cloud, or your infrastructure in the cloud, and then the least amount of visibility into that infrastructure when you're using software as a service by design. So the physical design of the data center A couple things we want to make sure that we're aware of for a physical data center. Now, I should say that we're looking at this from two perspectives in this course. We're looking at this from the perspective if we're building our own private cloud, or if we're, if we're building a virtualized data center, a data center to support virtualization. We want to make sure that we follow some of these design best practices. So obviously, we want to make sure that we design our data center where it has the infrastructure to support the human needs like clean water, power, food. It has necessary telecommunications, accessibility during and after a disaster. So location is important. Make sure we have a location that can, we have the capability. For example, you might be able to get cheap real estate in a large warehouse in the middle of nowhere, but there may not be internet available there. One of the things that's that you'll notice is a lot of times these large data centers are located in close proximity to major metropolitan areas because there's a tremendous amount of infrastructure available in metropolitan areas. Until you get to the huge data centers like Google and Amazon, where they can afford to have their own infrastructure, right? They can afford to build their own infrastructure for power. And if a huge data center is building somewhere, the telecommunications companies will follow because they follow the money, obviously. But for most of us, we don't have that luxury, so we have to make sure we design and plan for that. There's physical security requirements such as perimeter protections like walls, fences, gates, electronic surveillance. If you take an IT security class, or if you've already taken one, you probably already discussed a lot of the physical security or things you can do for physical security. Access points to control ingress and egress, which is basically exit and entrance, right? So ingress and egress are a fancy way of saying coming in and going out. Verify identity and access authorization with an audit trail. In other words, when people enter the data center or the complex and exit the complex, you have some record of that, so you know who was there and when and where they went, and being able to monitor to prevent theft. So some of the physical security attributes. Build or buy is basically, if you read in the textbook when they talk about build or buy, it's the question of what do we outsource and what do we build ourselves. But you can read more about that in the textbook. It's not terribly important in this discussion. But so some design standards. So there are some data center design standards that you can look at. I like standards and frameworks because they give us a kind of a good roadmap, a good template on how to do things and follow industry best practices that have already been established. And those industry best practices are established and codified in some of these standards for data center operations and data center design. The first one is the Building Industry Consulting Service International. The second one, the International Data Center Authority, which is probably a good resource. And then the National Fire Prevention Association, which has guidelines for fire prevention. Obviously, in the data center, there's some special concerns with fire prevention, which you probably learned about in an IT security class. But again, we have, so where this affects virtualization and cloud security is our data centers are very high density. And with that high density, you have to have special considerations for fire prevention and things like that. So that high density does introduce some issues. When you look at data centers, usually data centers are categorized as tier 1, tier 2, tier 3, and tier 4. So a tier 1 is just your basic data center that follows it has they follow the basic guidelines to build a data center. It has the necessary power, cooling, and infrastructure to run basic data services. But this is not something we would look for in a cloud service provider. We wouldn't expect the cloud service provider to be in a tier 1 data center. We would expect them to be in a tier 4 data center, which is fault tolerant site infrastructure, which in fact we saw with Azure. So when you set up your Azure VM, one of the things it asked you in the free Azure, the $200 credit that we had, is where you wanted your virtual machine to be hosted in US East, US West, US Central, and so forth. I don't know if they gave you a choice. Sometimes they kind of lock you into just three or four locations with Azure when you have the $200 credit. But you saw that they have these fault-tolerant site infrastructure where your machine can seamlessly run in multiple locations. And if one location goes offline for some reason, the other location can, all that traffic can be shunted to the other location. So they have a tremendous amount of fault tolerance, and they do categorize themselves in tier 4. And then you have tier 2 and tier 3. So tier 2 is redundant site infrastructure and capacity components. Tier 3 is concurrently maintainable site infrastructure. In a data center, you have to make sure you have tight control over temperature and humidity. So you have to look at your server inlet and exhaust. So you design it in such a way that you have cool air moving into the racks and hot air coming out. Usually, you don't want to mix those two. You have a hot row and a hot aisle and a cool aisle in data centers. There's ways to design them. And a lot of those guidelines you'll find in those standards and frameworks that I talked about. Typically, you have a floor tile supply temperature, so that there's air handlers that are supplying air from below the floor through the tiles. HVAC unit return air temperature, computer room air conditioning unit supply temperature. There's all these HVAC terms, but basically HVAC is really a topic unto itself. I almost feel like when I teach these classes that HVAC, we don't really give a lot of consideration to HVAC. We just assume that it's just this big machine that gives us cold air. And there's a lot of science and a lot of work behind effective air conditioning, and it can make or break a data center. HVAC, or heating and cooling, really mostly cooling, right? And temperature and humidity control is super important in data centers. And you would think that you could just pump a whole ton of cold air into a data center and you'll pretty much be able to handle whatever air handling needs you have in a data center. But there's also humidity. You have to make sure you maintain the correct humidity, and properly sizing and designing HVAC installations is important in data centers. You can't just throw a bunch of air conditioners in there and hope for the best. There is a whole engineering discipline behind HVAC design for data centers, and where this becomes really important for data center design for virtualization and cloud computing is going back to that high density. So we have such high densities that we need in our data centers for virtualization that HVAC becomes a really important component to make sure that we're adequately cooling our data centers. And I should also mention that HVAC represents a pretty significant cost for operations with data centers. So if you don't design HVAC correctly, it can cost a lot more money than you need it to. A lot of us make this mistake in our own homes. We have air conditioners that aren't sized correctly. I would be willing to bet that of all of you that might be in a class, if there's 25 of you in a class, if I had all of you do an analysis of your air conditioning in your homes, and you did what's called a manual J load calculation, and you do all the measurements and you do all the observations, and you put all that into a manual J calculation, and then you do a manual S calculation to figure out what type of units you need for air handling and for cooling capacity, I would be willing to bet that probably 80% of you have mostly oversized air conditioning, which means you're spending more money than you need to and getting less adequate cooling in your homes. I'll give you a good example. A lot of people think if they have an air conditioner, it should only run, a few hours a day. But really, the design temperature for residential air conditioners, if you build it and design a residential system, it should run most of the day when the sun is out. So if your air conditioner pretty much runs all day, you probably have a properly sized air conditioner, and a lot of people don't see it that way. And the reason that that's a good size is because even though it's running constantly, air conditioners are much more efficient the longer they operate. So you get much more efficiency. And by the way, if an air conditioner runs for less than 30 minutes, you're not getting the dehumidifying effect of the air conditioner, which means that the air is going to be much less comfortable in your home, for example. So there's a lot of little things that go into HVAC design that can have a drastic impact on the cost and effectiveness of those systems. So again, it's something really, I recommend looking into how HVAC works and how these systems are designed, because it's a really important component of data centers, and it's certainly something I familiarize myself with, and it also help you in other areas of life if you ever have to do any work on air conditioning or something in your home, for sure. But it's good to have an understanding of that stuff because of the expense, right? So thinking about your home, a significant portion of your electric bill in the summertime is probably from air conditioning. And imagine that on a much higher scale, right? You maybe have a 2,000 to 3,000 square foot home, or maybe smaller, or maybe a little bit bigger, who knows? But most residents fall somewhere in that range. I think the average residence in the United States is 2,200 square feet. And if take that and multiply it by 1,000, and now we're talking about the cooling needs of a data center. So take your electric bill and multiply it, and that's a significant amount of money to be throwing, to basically have pumping out a window, which is essentially what you're doing with improper design. So a lot of these things, and I could go on and on about power and about power design needs within data centers and those types of things, and they have the same types of requirements. Cable management is important in the data center. Usually cable management is either going to be underfloor or it's going to be overhead with ladder racks overhead that the cabling kind of winds through your data center. It's important that the cabling does not interfere with the cooling, so that can affect how the cooling works if you don't, if you're not designing these things in concert with one another. Obviously, cabling is, you think how much obstruction could a cable possibly have, and I'm sure most of you have seen inside data closets, a couple Cat5 cables use a lot of volume of space. And if you have these huge bundles of cabling everywhere, that's a significant obstruction. So it's important to be aware of that. Cable congestion and raised floor plenums. Basically, a raised floor plenum means that there's airflow under a raised floor. Plenum is basically a place for airflow and for wiring. It can reduce the total airflow as well as degrade the airflow distribution through the perforated floor tile. If some of you may have been in data centers where you may have noticed that the raised tile floor has these perforations into these little holes, and that's where the air can come up. Excuse me. And really, again, all this depends on how it was designed. Different data centers use different methods. Some data centers, the cooling is actually inside the rack. Some data centers, they cool the ambient air temperature from overhead. There's lots of different ways to do this, and same with the cable management. Again, sometimes it's overhead, sometimes it's under the tiles. It really just depends on how you designed it.